Hi everyone, this is Kalyan Kumar, and here I present another video on the IUPAC nomenclature of various organic compounds. In this edition, we're going to look at cyclic cyanides. So let's start with understanding what are cyclic cyanides. Now, cyanides in the previous video already seen are the ones which have the C triple bond N. So C triple bond N is a cyanide, and now it's attached to a ring. So how are we going to name this? Very similar to carboxylic acids. We call this as cycloalkane, and this, when it exists outside the ring, would be called carbonitrile. And by default, the alpha carbon here in the ring is given the position number 1. So let's check out the first rule. When a nitrile group is added to a ring, the suffix carbonitrile is added to the name of the cyclic compound. The ring carbon attached to the nitrile group is given the position number 1, and that would be its location number. So let's do a couple of examples and see whether we're able to get the names right. As usual, pause the video, name it, and then play it back. So in this one, this carbon is the carbon 1, the alpha carbon. And we will go clockwise so that we can give this fellow sitting here the number 3. So the numbering is done this way. So it's 3-ethyl cyclopentane carbonitrile. And let's try one of them, which is pretty complicated. The parent, as you can see, it's a 6-membered ring, cyclohexane carbonitrile. And let's understand how to give the position numbers. Now, if I were to give it anti-clockwise, I'm going to give 1, 2, 3, 4, 5, 6. And I've got 2 people sitting at 3. So the position numbers are 1, 2, 3, 3, 4, 5, 6. Let's do it the other way around. Let's rub this off. And now let's give the numbers clockwise. 1, 2, 3, 4, 5, 6. So I got 1, 2, 3, 4, and I got 2 people sitting at 5, and then 6. So which numbering do you think would be preferred? Obviously the number where you get the lowest value at the first point of difference. So we are going to look for this one. So the numbering is done anti-clockwise. 1, 2, 3, 4, 5, 6. So it's cyclohexane carbonitrile, and then you have all these substituents. If you want to look at the substituents, 1, 2, 3. And this fellow is prop-1-inyl, vinyl, allyl, methyl, ethyl, isopropyl, and propyl. And now arrange them in the correct alphabetical order. 3 allyl, 5 ethyl, 6 isopropyl, 1 propyl, 2 prop-1-inyl, 5 methyl, 3 vinyl, cyclohexane carbonitrile. So just go through this once again. And if you have any questions, you can always drop them in the comment section. But we still have got certain more stuff for you in cyclic cyanides. What if there is a cyanide group attached to an acyclic part, and the acyclic part is attached to the ring? In such an event, the acyclic part becomes the parent and the ring becomes the substituent. If the cyanide group is not directly attached to the ring and attached to an acyclic part, then the acyclic part is the parent and the ring is a substituent. Let's do an example. So what would you call this? This is the parent. Numbering done this way. So it's 3-cyclohexyl propane nitrile. What about if the cyanide exists in the ring as well as the acyclic part? Then irrespective of the number of carbons in either case, this ring happens to be the parent. If a cyanide group is attached to a ring as well as an acyclic part, which is itself attached to the ring, then the parent is the ring and the acyclic part is the substituent, irrespective of the number of carbons in the ring and the acyclic part. Let's take an example. So this is the parent, cyclohexane carbonitrile, substituent. Let's do the numbering. This is the numbering of the ring, numbering of the side chain. So the prefix for CN is cyno. So it's cyno sitting at 7 and this entire thing is sitting at 2. So this is going to be 2 bracket open 7 cynoheptyl cyclohexane carbonitrile. 2 7 cynoheptyl cyclohexane carbonitrile. Alright, what happens if 2 rings are attached to each other? Both have cyanide. Well, if they are of the same size, you can use any one of them. If they are of the same size, one has more substituents, the other is less. The one which has more substituents is the parent. But if the sizes are different, then the one which is bigger, that is the parent. If 2 rings are attached to each other and both carry a CN group, then the smaller ring is the substituent and the larger ring is the parent. This is the parent. So this is cyclohexane carbonitrile. That's pretty simple. What do we call this one? Well, this carbon is 1 and this carbon is 2 because this is the parent. So we need to have the carbon attached to the parent as 1. This is 2. So this is 2 cyno. And this itself is sitting at the position 2. So it's 2 bracket 2 cyno cyclopentyl cyclohexane carbonitrile. 2 cyno cyclopentyl cyclohexane carbonitrile. So this is it for cyclic cyanides. We have tried and seen all possible permutations and combinations. If you still have any particular question on it, drop in at the comment section. And I thank you for watching this video.